4, trigonometry. Why do we care about trig? Trig appears all around us. If you look at the diagram right here, it's actually showing a roof truss on a house that's being built. And it's created using 2x4s. And if you look, it's actually in the shape of an equilateral triangle. Okay? And the inside triangle inside it is constructed. So if you look, you've got this triangle here, PAQ, that's similar to triangle PQR. And BR is 1 meter, RC is 2 meters. And they want to know how long the 2x4 should be for the following sides. AP, which is the side here, AQ right here, and PQ. How do we do that? We need to remember what we know about trig and what tools we have that could help us solve triangle problems and how and when they're used. First thing we need to know is how to create our diagrams to be able to use our tools. Things to remember are capital letters are always used to denote angles. So you'll see in the triangle here, I've got a capital A, a capital B, and a capital C for the vertices. And lowercase letters are used to denote side lengths. So I've got a lowercase a, and you'll notice it's opposite angle A, and a lowercase b to represent side B, which is opposite angle B, and a lowercase c to represent side C, which is opposite angle C. The Pythagorean theorem is also another useful tool, which we know, and it's used to solve for the missing side in a right triangle when you know the other two sides. So that's really important. It has to be a right triangle, and you have to know two sides. Pythagorean theorem tells you that the square of the hypotenuse, which in this case is side C, is equal to the sum of the squares of the other two sides. So if I take the other two sides, A and B, I square them both, then add them together, I get the square of side C, which is the hypotenuse. In addition, we learned last year about similar triangles, and we know that if two triangles are similar, then their corresponding angles are similar. So if we have triangle ABC and it's similar to triangle GFH, I look at order. Angle A is first in both of them. Angle A is equal to angle G. B is the middle angle, so it's going to be equal to the middle angle in triangle GFH, which is F, and C is going to be equal to H. The ratios of the corresponding sides are also equal, and we can read that off in order. AB, the first two letters, over GF, the first two letters in the other triangle. BC, the last two in the first triangle, over FH, which is the last two in the second triangle, and AC, first and third, over GH. Or I could simply have used their letters, or their lowercase letters, C over H, A over G, and B over F. In addition, we also know the ratio of the squares of the corresponding sides in similar triangles is equal to the ratio of their corresponding areas. So if I take this ratio of the corresponding sides and square everything, I can set it equal to the area of the two triangles respectively, or sorry, to the ratio of the areas of the two triangles. Last thing we need to remember from grade 10 is trigonometry, the primary trig ratios. And what is trigonometry? Well, trig is a branch of math that studies triangles, and the basic trig ratios involve the relationship between the side lengths and angles in a right triangle. Again, it has to be a right triangle to use the primary trig ratios. Now, what's really important here is we need to make sure we're using, referring to the right angle. Okay, what do I mean by referring to the right angle? Well, when I talk about that, what I'm really talking about is what angle am I doing my trig ratio based on. So if I look at this angle here, theta, it's opposite this side over here. But this side here that's creating that angle is the adjacent side to it. And this angle here, phi, is its opposite side is over here, but its adjacent side is right here. The only part that didn't change was the hypotenuse, because the hypotenuse is always opposite the right triangle. The primary trig ratios are made up of three ratios: sine, cosine, and tangent. And they're usually shortened up to be just the first three letters of the ratio. Sine theta is opposite over hypotenuse, or O over H. Cos theta is adjacent over hypotenuse, or A over H. And tangent theta is opposite over adjacent. And we can use SOHCAHTOA TOA to help us remember that. When we're using the primary trig ratios to solve a problem, the first thing I have to do is always label my hypotenuse first. It's opposite the right angle. Other things I need to remember, the angles in a triangle always add up to 180 degrees, and that's any triangle, not just a right triangle. The word solve tells me to find all the missing information, side lengths and angles. When I'm using my calculator and I want to evaluate a sine of an angle, so sine 45 degrees or cos of 45 or tan of 45, I always have to, I'm going to have to press just sine and the number on my calculator. And I can't just say sine, cos, or tan. I have to have a value after it, or I have to use a capital letter for the angle. When I'm solving for an angle, I have to use the inverse of the sine, cos, or tan function on my calculator, and that may require me to use a shift button or a second function button. Every calculator is different, so you're going to have to play with your own calculator. And the last thing to remember is when you create your trig ratios, your unknown side lengths could be in the numerator or the denominator, and the best way to solve it and make sure you solve it correctly is to use a proportion. So I'm going to pause this for a minute here. There we go. Sorry about that. I needed to get my toolbar back so I could get my highlighter. First example is asking me to solve a triangle given angle A is 36, angle C is 90, and side B is 12 centimeters. Side lengths I have to state to the nearest tenth of a centimeter, and angles to the nearest degree. So what am I doing? I'm solving. That means find all my side lengths, all my angles, nearest tenth of a centimeter, and nearest degree. So the first thing I need to do is draw a triangle. Everybody meet my dog. This is Angel that you hear barking. Angel, stop. Okay, so I have to label my angles. Angle C is 90 degrees. It doesn't matter which angle I make A, because angle A is 36 degrees, and what I have to do is make sure my sides are labeled appropriately based on that. I told my other remaining angle then is angle B, and I have to label side C, which is going to be opposite angle B, and it was 12 centimeters. To finish off labeling the triangle, I'm going to call this side A because it's opposite angle A, and this side C because it's opposite angle C. Let's just clean this up a little bit so we can see it better. Now, what skills can we use to solve that problem? I don't know two sides, can't use Pythagorean theorem. I don't have a second triangle, I can't use similar triangles, but what I do have is a right triangle, a side length, and an angle. That does kind of lead me to the idea of using trig ratios. The other thing I have to remember, which I forgot to mention, was the sum of the angles in a triangle is always 180 degrees. So we know angle A, we know angle C, we know side B, we need angle B, side A, and side C. The easiest thing to solve for here, I could solve for a missing angle or a missing side length. The missing angle, of course, is going to be the easiest because I know one angle, two angles. They have to add to be 180 degrees. So I can just do 180, subtract angle A, subtract angle C, and I get angle B is 54 degrees. Now, if I go backwards here, for the angle I was given, and I always try and stick with the angle I was given in order to solve a problem. For that angle, I know this side here, which is my adjacent side. C is opposite my right angle, so it's my hypotenuse, and A is opposite the angle I was given. So that's important to be aware of, because that's going to help me determine what I need to do. Oops, I went too far. So if I want to solve for side A, I've got I'm looking for the opposite. I know my adjacent, and that's my tangent ratio. So tan is opposite over adjacent. Opposite was A, adjacent was 12, and I've got the tan of 36. What's important to remember is treat this like a proportion, so I write tan 36 over 1 equals a over 12. And we know that to solve this equation, I can do what's called cross multiplying, which is a shortcut for solving equations, because really what I'm doing is multiplying both sides of the equation by 12 to eliminate the fraction on the right side, and I multiply both sides of the equation by 1 to eliminate the fraction on the left. So I end up with a is 12 tan 36, so it's approximately 8.7 centimeters. The last thing I need to do, I've got side A, I've got side B, or angle B now, I've got side A, I need side C. I do know two sides in a right triangle, so I could use Pythagorean theorem to solve it, but if you think back to what we did here, we rounded side A, so it's not completely accurate, and it requires a little more work on our calculator to keep the decimals of accuracy, but you can use your memory button or just work with the number you have. The alternative is I've got my adjacent, I'm looking for my hypotenuse, and that's a cosine ratio. So the cosine ratio is 12 over c. And what's interesting with this one is when I set it up as a proportion, I'm going to multiply both sides by c and multiply both sides by 1, and I end up with c cos 36. In order to get that c by itself, I have to divide both sides by 12, and I've solved for side c. If I had used the Pythagorean theorem, I would have had c squared is a squared plus b squared. Notice what I did here. I kept my value for side A exactly here on this page. It's 12 tan 36 degrees. So when I substituted into the Pythagorean theorem, I left it as 12 tan 36 because it gives me that little bit more accuracy when I'm trying to solve. Okay, so now I'm going to put that in. Now that 8.7, when I've got it on my calculator, I'm not rounding it on my calculator. I'm keeping all the decimals on my screen. I'm hitting my exponent button to square it. Then I'm adding 12 squared. And you can see I've put all these lovely decimals here to show you what I'm doing. And then I square root it. And I've got a good answer for C. If I try and round this here, my decimals will be off and I will lose accuracy. And that's it. Before tomorrow's class, please do exercise 1, page 2, questions 1 to 4.